So we have curve, right? Y equals f of x. And we want to know what is the length of the curve. Y equals f of x when x is between a and b. Right? So we have two endpoints, and we want to know what is the length of that curve between these 2 points. So what we'll do our usual thing which we'll do in calculus. Instead of finding something, we find its approximation. Then we take limit of approximation, and for the limit stage, we're going to get our acceptance. But the first one is approximation. To approximate, we divide the whole thing into smaller pieces. Then we approximate small piece, add up all the approximation, get approximation to the whole piece, and again, take the limit of approximation. What we'll do is the following. So somewhere on the bottom here, we have our x-axis, right? So x equals to a, and x equals to b here. Then we're going to divide that interval into small subintervals, find delta x. That in turn will divide our curve into pieces, right? And then we're going to take a look at one particular piece, say this one. Okay, so one particular piece. So length of this piece. Now we approximate length of this piece. So we approximate by saying we can approximate it by doing that straight line, right? So we can connect the end pieces of a smaller piece by straight line. This. And now to find that piece, what we do is we realize that we see right triangle. And in that triangle, right triangle, we have delta x and delta y. So delta x and delta x is horizontal, delta y is vertical. Now we can approximate hypotenuse of that right triangle. So we're going to get square root delta x squared plus delta y squared. So we got the following, so total length it's going to be approximately equal to square root of I from 1 to n delta x squared plus delta y, I guess I squared. Okay. So that is approximation for total length. When we take limit of that approximation, so we take limit of that approximation when we take smaller and smaller pieces, when delta x approaching 0. And that's going to be length. We're going to call it arc length. Arc length of the curve. And eventually we're going to get, if you remember, at the limit stage, sum becomes integral. We start it at x equals to a. We finish our division at x equals to b. And inside here, we're going to get dx squared plus dy squared. and that's arc length. So basically we got integral. The only thing when you look at this integral, you kind of say it's kind of weird integral. It does not have dx or dy at the end. So we'll need to do a little bit of algebra here to get dx at the end, but we're basically done. So what we'll do is we'll fall in. So I want to have dx at the end. That's the missing piece. So what I'll do is, because that's extra stuff which I put, to balance it, I have to divide by dx. Now I'm going to bring that dx inside of square root. To bring it inside of square root, I will have to square it. And eventually we're going to get the length of the curve. Y equals f of x when x is between a and b equals integral x equals to a, x equals to b, dx. And here I will distribute the division. Dx squared over dx squared is 1. Dy squared over dx squared is dy over dx, which is derivative y with respect to x. And that's a formula we are looking. Find the length of y equals to x squared when x is between 1 and 2. So we have our formula. Derivative squared dx. So we know we start integrating at 1, finishing at 2, square root, 1 plus derivative of x squared is 2x. Okay. So we get integral 1 to 2, square root of 1 plus 4x squared dx. And we'll do this integral in about 2 weeks. Find the length. So this one we will be able to finish of y equals to x to 3/2 when x is between, say, 1 and 3. Again, we have our formula, 1 to 3 square root, 1 plus derivative squared dx, 1 to 3 square root of. So let's find the derivative. 1 plus derivative will be 3/2 x to 1/2. I get to square it. Integral 1 to 3 square root of 1 plus 3 squared is 9, 4, 2 squared is 4, x to 1/2 squared is x. So I'll do substitution. U equals 1 plus 9 quarters x. Du equals 9 quarters dx. Dx equals multiplied by reciprocal 4 over 9 du. x is between 1 and 3, u, which is 1 plus 9/4 x, is going to be between, substituting 1 for x, we're going to get 1 plus 9/4. 9 plus 9/4 is going to be 13/4. Substituting 3 for x, we're going to get 1 plus, I'll do it somewhere inside, 1 plus 9/4 times 3, so 1 plus 27 over 31 over 4. So that's going to be on top. So that's a substitution which you will do. So when we do substitution, we're going to get integral u equals to 13/4, u equals 31/4, square root of u, and 4 9 3 u. So 4 9. We're going to treat it as a u2 1/2. Antiderivative of u2 1/2 is u2 3/2. Multiply by reciprocal 2/3, and we do it from 13/4 to 31/4. 8 over 27, 31/4 to 3/2 minus 13/4 to 3/2. And at this point, grab a calculator, do the calculations, approximate your answers to a couple of decimals, and be done with it. So if I'm correct, I got 4.6566. So I got 4 decimals.